Okay, so what happens if there is no slanted asymptote? What if there's no horizontal asymptote, right? We asked this question before, though we sort of left it hanging in the air. We just said there is no horizontal asymptote. But sometimes we do get a curious feature. That is, we get something called a slant asymptote. And specifically, this happens whenever we have a rational function in which the degree of the numerator is exactly 1 greater than the degree of the denominator. So before we go sketching any more graphs here today, we need to take a moment and let's figure this out. How do we figure out what the slanted asymptote of this is? We know that the degree of the numerator is 3 and that the degree of the denominator is 2. This fits the slant asymptote definition in this case, so the degree of the numerator is exactly 1 greater than the degree of the denominator, but it doesn't tell us how to find that slanted asymptote. And I'll tell you that the way that you really find that slanted asymptote is by doing long division. Okay, long division. Let's remind ourselves how that goes. Our divisor, x squared minus x minus 6 in this case, will be divided into the numerator negative x cubed minus 4x squared minus x plus 4 in this case. Now, we're not particularly worried about trying to find factors of the numerator and denominator and reducing. If we could, we probably should do that, but we're still going to have to carry out this division one way or the other. So let's go ahead and carry it out directly. What would we have to multiply by x squared to get negative x cubed? The answer is negative x. So negative x times x squared gives me negative x cubed. Negative x times negative x, that's plus x squared here. Negative x times negative 6 is plus 6x. So we're going to subtract that away from the line above it. We're going to get negative 5x squared. Looks like minus 7x. And it looks like plus 4. Put that. Okay, so now we need to take x squared and figure out, well, what would I multiply to get negative 5x squared? That's going to be minus 5. So we're going to have minus 5x squared. Minus 5 times negative x, that's plus 5x. Minus 5 times negative 6, that's plus 30. So now we're going to subtract that from the line above it. And we're going to get negative 12x. Looks like minus 26. And so what does that tell us? Well, if you recall, when we divide a polynomial by another polynomial, our result through long division, or any other kind of division for that matter, is equal to the quotient. In this case, that's negative x minus 5 plus the remainder over the divisor. So it's plus the remainder of negative 12x minus 26 divided by x squared minus x minus 6. Whatever else happens on this function, here's what is definitely going to be happening to our polynomial. I'm going to see if I can write this out a little bit more neatly. Whatever is going to happen to the rest of our polynomial right here, as x gets big, this part of the expression is going to go towards 0. But as x gets big, this part of the function takes over. And this is what we call a dominant graph behavior, and that dominant graph behavior is our slanted asymptote. We will say that our slant asymptote is the quotient that's left over by dividing a polynomial of degree 1 greater than the degree of the denominator. And so our slant asymptote is in fact going to be the line y equals negative x minus 5. And so that's how we find it. We do a division, and our quotient turns out to be our slant asymptote as a result. Okay, more to come.